do I solve this part of the question? What will Master Galileo say?
He doesn't know how to square root.
Galileo, I am sorry. I am not worthy to be your pupil. I am a failure.
I came from the future! Tell me, fellow human, what year is this?
It's just horrible.
What, who, me?
I can't solve this part of the question. There is no way. There is just no way I can solve this.
Oh, why, never fear, fellow human, for this is what you need.
Texas Instrument Calculator, the best calculator ever. Visit ti.com for more information.
Hello and welcome to the best YouTube channel featuring me, your favorite online celebrity. Last week, I built a time machine.
Yes! Yeah!
And I have successfully traveled back in time to the 17th century, where I met Vincenzo Viviani, who was Galileo Galilei's disciple. Vincenzo Viviani will help me solve a physics question related to object motion and kinematics. And here he is, the man himself. Buongiorno a tutti! It's strange, why are we staring at this device? I will never understand future people. Sorry. Okay, let's go to the whiteboard.
And so here we are, the filming booth. The whiteboard, we're gonna be watching Vincenzo Viviani teach us physics. I already wrote the question on the board. He's coming right now. I'm just gonna sit here, watch him solve the question for us. And yeah, we're gonna watch this man from the past solve a physics question. He's coming right now.
Wow.
Yeah, here we are.
A lot of people in the future, they're so rich. Where do I stand?
Stand over there,
Here? Oh, okay.
and you look up at the camera. And don't forget to introduce yourself. Yeah.
Hello and welcome everyone. My name is Vincenzo Viviani and I'm from Italy. Today I'm helping my good future friend to solve a physics question. The question is, if a ball throws a ball upwards at 23.4 meters per second, and the question wants us to determine the distance of the ball above its initial position when it reaches the peak. There are a few things we can tell just by reading the question. So, the first thing we have to do is to visualize the situation of the question. And so, let's say this is Emma Ball. And she throws a ball at a velocity of 23.4 meters per second. This number is the initial velocity because it is how fast the ball is moving at the point of release. And so V1 is equal to 23.4 meters per second. What else do we know? We know that any object falling towards the center of the earth is accelerating at negative 9.8 meters per second squared. And we also know that at the peak, when the ball is traveling in the air, it goes up and it stops at some point and then it falls back down. So if I draw a time and displacement time graph, the ball at 0 seconds is at rest. And as time passes, the ball moves upwards. But it doesn't continue moving upwards. It will slow down due to gravity until at some point it stops. Because gravity has overcome the initial velocity. And it will start falling back down. That point over here, what is the velocity? The velocity is 0 because it is not moving. It is 0 meters per second. And so we'll consider this 0 meters per second our final velocity. So Vf is equal to 0 meters per second. This is what we're interested in. We're interested in the peak. Now, we are asked to find the distance from the bottom. So we're trying to find change in D at that point. So we're trying to find change in position at that point. So we're looking for change in position. And now we must find the most suitable equation for this situation. And that equation is Vf squared is equal to Vi. Sorry, I have to add the arrows. The arrows mean that they're vectors. Vi squared plus 2a 2 times acceleration times change in displacement. That is the correct formula for this question. And now all we have to do is plug in our numbers. Vf 0 squared is still 0, so it's just 0. Is equal to, what is the initial velocity? 23 meters per second. 23.4 meters per second. And squared. We don't have to write meters per second, we can just write 23.4 squared. Okay? And we continue, plus 2 times negative 9.8, that's the acceleration, times displacement. We want to find displacement, we don't know what it is. We're solving for displacement. Now, we have to move all the numbers to the other side so we can isolate the displacement. We'll save the calculations for later. So we don't have to worry about solving the square first, over here. So we can just move the whole thing to the other side, which becomes negative 23.4 squared. And that is equal to 2 times 9.8 times change in position. We also want to move this thing to the other side. And that becomes a division, because over here it's a multiplication. Once you move it to the other side, it becomes a division. And the equation becomes change in position is equal to negative 23.4 squared divided by 2 times negative 9.8. And so by using this incredible tool, we find that change in displacement or change in position is equal to 27.9 meters. And now we know that once the ball reaches the highest point, the peak, its height is 27.9 meters. All this is possible thanks to this ingenious device. This is incredible. We just punch in the numbers and the answer pops out.
I'm sorry, I have to stop Vincenzo Viviani because if I were to let him talk, he would go on for hours just describing how good, how wonderful the calculator is. And right now I am preparing to send him back into the past, 1672, where he belongs. I can't keep him in the future forever, and like all good things, this just has to end. It's pretty hard for me as well. And yeah, we're preparing to say goodbye.
And I am back home. Thank you for bringing me to the future, my friend.
Farewell.
Farewell.
Farewell, Mr. Viviani.
Ciao.
Bye.
Wait! You forgot this? Whew. Time traveling is tiresome.
Let's see what's on the news. Probably just inflation.
Recent inflation is not the only concern on people's minds these days. Archaeologists in Italy have found a calculator hidden deep within the personal documents of Vincenzo Viviano, who was Galileo Galilei's apprentice and disciple. We do not know what this means, but folks, this is exciting.